Hello, and welcome to Business Calculus, the Quotient Rule. We saw last time that differentiating the product of two functions requires special care. It turns out that the derivatives of the quotient of two functions also have a special rule associated with them. Let's look at an example to show why that must be the case. If we have a function t of x equals x cubed, and a function b of x equals x squared, and we want to differentiate their quotient, the top function divided by the bottom function, we have x cubed divided by x squared, which is equal to x. The derivative f prime is equal to 1, according to the power rule, but we see that the derivative of the top function is 3x squared, and the derivative of the bottom function is 2x, and if we take the quotient of those two functions, we get 3x divided by 2. Clearly, the derivative of the quotient is not the quotient of derivatives. It follows the quotient rule. If f of x is given by a function t divided by another function b, and the derivative of t and the derivative of b exist, then we say the following. The derivative of the quotient of two functions is the derivative of the first function times the second function left alone minus the derivative of the second function times the first function left alone, all over the denominator squared. Read aloud, this statement is very similar to how we said the product rule aloud. And you need to get used to saying both rules, so go ahead and repeat it one more time. The derivative of the quotient of two functions is the derivative of the first function times the second function left alone minus the derivative of the second function times the first function left alone, all over the denominator squared. Let's look at some examples to practice using the quotient rule. We have y equals t squared minus t divided by t squared plus 1, and we would like to calculate the derivative y prime. So y prime is going to look like the derivative of the first function times the second function left alone minus the derivative of the second function times the first function left alone, all over our denominator squared. Okay? Now we're going to take the derivative of t squared minus t, and we're going to get 2t minus 1. We're going to keep it in parentheses because we're going to have some multiplying to do here in a bit. And then t squared plus 1. And then we're going to subtract from that the derivative of t squared plus 1 times t squared minus t. The derivative of our function here is just 2t, and then times t squared minus t. Okay? Now, looking at what we have, remembering, of course, to write our denominator, we want to see if there's a way to simplify the numerator. So we're going to go ahead and multiply all of this out and get 2t squared, taking the 2t cubed, taking the product of our first two functions in our binomial. Then we're going to look at the inner terms and get minus t squared. Then we're going to look at our outer terms and get plus 2t. And then finally the product of our last two terms and get negative 1. From that, we're going to subtract 2t cubed plus 2t squared, which is the product of our last two functions. And of course, all of this goes over the denominator squared. Okay? Now we would like to combine like terms. This term and this term add out. and this term is like this term, so we can add them together. So what we're going to see is t squared plus 2t minus 1 all over t squared plus 1 quantity squared. All right, let's look at another example. Here we have f of x equals 3e to the x all over 1 plus x. Applying the quotient rule to this function, we have the derivative of the numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone all over the denominator squared. Okay? Now we look at the derivative of 3e to the x power, which is just 3 times the derivative of e to the x, which is e to the x. And then we multiply that times the quantity 1 plus x. And from that we subtract the derivative of 1 plus x, which is just 1, times 3e to the x. We see that after we copy down our denominator, our numerator has a common factor. That common factor is 3e to the x. After pulling out that common factor, we're left with 1 plus x and then minus 1 in the numerator. And then in the denominator, of course, we have 1 plus x quantity squared. So 1 minus 1 is 0, and we have x left over in the numerator, so that simplifies to be just 3x e to the x divided by 1 plus x quantity squared. All right, we have one more example to look at. We would like to take the derivative of the natural log of x divided by 2x plus 5. So we take the derivative of the top function and multiply that times the bottom left alone. And we subtract from that the derivative of the bottom times the first function left alone. And then that is all over the denominator squared. Okay? Continuing on, we have the derivative of the natural log of x, which is 1 over x. And we're multiplying that times 2x plus 5. And then we are subtracting the derivative of 2x plus 5, which is just 2, times the natural log of x. We take all of that over our denominator. Okay? Now, this is already looking like the numerator isn't going to clean up very nicely, but we'll do our best. We're going to have 2 plus 5 divided by x, and then we're going to have minus the natural log of x, all over our denominator of 2x plus 5 quantity squared. All right, what I would like for you to do now is to determine the derivative of the following function using the quotient rule. Here are some potential answers. and I would like to thank you very much for listening.